So, hello student. In the series of revision classes of physics, we are here on the chapter system of particle and rotational motion. Today in this chapter, I will discuss about the system of particle and rotational motion. Firstly, I will discuss all the concepts in very short. Now and then I will solve some previous year question. Okay. So our chapter name is system of particle and rotational motion. System of particle and rotational motion. So the name of chapter is system of particle and the rotational motion. First thing we have to know what is the particle and what is system. A particle and a system. So particle is defined as an object whose mass is finite but size and internal structure can be neglected. So mass will be there but size will not fixed. Okay. So that was this particle. Mass will be negligible. You can take the mass of the particle will be negligible. Okay. The system is a collection of large number of particles. So collection of large number of particles. Now next thing is two. There are two type of force on the molecule. Suppose that was a body molecule inside it. So they all are applying force to each other. That force is known as internal force. Internal force means a force which exerted by the particle is no which exerted by a particle on each other is known as the internal force. Now next is external force. External forces we apply from outside to the system. So that was our external force. So internal force means the force which the particle exerted on each other, and external force is the force which we do from outside of the body. Now next is center of mass. Next is our center of mass. So the center of mass of a body is a point where whole mass of the body is supposed to be concentrated. Is supposed to be concentrated for describing is translatory motion. What are the translatory motion and rotational motion? I will discuss later. Now, firstly, let me know the definition of center of mass and center of gravity. Concentrated for describing the translatory motion. So generally the center of mass is a point where the whole mass of the body is supposed to be concentrated. It is not as the center of gravity, huh? It can be at any point where the whole mass is supposed to be concentrated. And the next point is the center of gravity. The center of a gravity is where the whole weight of the body is concentrated. Now next is your center of gravity. Center of gravity always come in the middle point, but not center of mass can be in the middle point and cannot be in the middle point of the object. So center of gravity, it is a point at which the resultant of the gravitational forces, the resultant of gravitational forces on all the particles, on all the particles of the body acts. That means a point where whole weight may be concentrated, may be concentrated. So it always come in the middle point of the object, but center of mass cannot come, can may become or not become at the middle point. Now suppose let's see some example. I am taking some example. Suppose there is a thin rod. In thin rod, the center of mass and center of gravity coincide at a point that was at its middle point. Okay, center of gravity always remain at its middle point. In the ring, center of gravity and center of mass always at single point. Okay, that was at middle point. In the disk, also center of gravity and center of mass are at middle point. But now come at the part of cylinder. In the cylinder also, center of gravity and center of mass coincide with each other at the middle point of the height. Okay. In a sphere also, the center of gravity and the center of mass coincide at a single point at its middle point. Sphere, that's what cylinder. But now in the case of cone, center of gravity and center of mass not coincide with each other, because center of mass is come at the middle point and center of gravity come at the middle point and the center of mass is at h by 4 height. Okay, so center of mass is at h by 4 height from its base. This is the height of the cone, so center of mass is located at h upon 4 from its base. So that's why center of mass and center of gravity does not coincide with each other. In center of mass is a point where whole mass of the body is to be concentrated, and center of gravity is the point where whole weight is to be concentrated. Center of gravity is always at the midpoint, and center of mass may or may not be at the midpoint. So that both these two are different things from each other. Now, one of question come in your previous year from this chapter, that was distinguish between the center of mass and center of gravity. So the previous year question, which was repeated 2 to 3 times, is that one. They distinguish between center of mass and center of gravity. Center of mass and center of gravity. So one side you can take center of mass, and on one side you will take center of gravity. So it is a point at which entire mass of the body is supposed to be concentrated. Entire mass of a body is supposed to be concentrated. Supposed to be concentrated, and it is a point at which whole weight of the body is supposed to be concentrated. Whole weight of the body is act because we know that that was a fixed point at the middle of the object. The next is it refers to the mass of the body. It refers to the mass of the body it refers to the weight acting on all the particles of the body. On all the particles of the body. The next points of center of mass and center of gravity are center of mass and of center of gravity are in a uniform gravitational field. In a uniform gravitational field, center of mass and center of gravity, center of mass and center of gravity coincide, and in a non-uniform gravitational field, in a non-uniform gravitational field, in a non-uniform, the center of gravity and center of mass do not coincide, and center of mass do not coincide. Next point is center of mass of the body is defined to describe the nature of motion of a body as whole. The nature of a motion of a body as whole. Center of gravity of a body is defined to know the amount of stability of the body when supported. So that was your the difference between the center of gravity and center of mass. This question is repeated three times in your previous year question. So that was very important for your exam point of view. So you have to remember all these points and you can write all these points in your examination. Now the next one is your center of mass and center of body will be clear. Now next is center of mass of two particle system. Next topic is center of mass center of mass of a two particle system. Center of mass of a two particle system. Now, what are the two particles? Suppose that are the two particles on the axis, that was axis x axis, y axis. Suppose that was the point P of mass m1 at position r1, and that was a point Q of mass m2 at position r2. So their center of mass suppose to be concentrated at point C. So the position vector of point C will be denoted by RCM vector. RCM vector means the position vector of the center of mass. Center of mass is at C point will be M1 R1 vector plus M2 R2 vector upon M1 by M2. M1 plus M2. If both the masses are equal, so if both the masses are equal, masses are equal, so M1 equal to M2 equal to M. So RCM vector is equal to M of R1 vector plus M of R2 vector upon M plus M. It became 2M. So R1 vector plus R2 vector by 2 will be its value. Okay. Now if it come in the coordinate axis, so the value of XCM will be M1x1 plus M2x2 upon M1 plus M2. Similarly, the position vector of YCM will be M1Y1 plus M2Y2 upon M1 plus M2. And similarly, the position of ZCM vector will be M1Z1 plus M2Z2 upon M1 plus M2 will be the position vector of ZCM. Okay, so that are the position vector. Now, if there are n particle system, so system of particle of center of mass of n particle system, center of mass of n particle system, and particle system means in the particle which have n number of particles and particle system. In previous topic there are only two systems. Now I am considering a particle which have number of system. That's what x, y, and that was z axis. So that was the particle in which the position vector are r1 vector, r2 vector, r3 vector. So that was m1 at position r1 vector, that was m2 at position r2 vector, that was m3 at position r3 vector, and that one is your mn at position rn vector. So generally the value of RCM for the center of mass of n particle system will be m1 r1 vector plus m2 r2 vector plus m3 r3 vector, m3 r3 vector plus dot mn rn vector. Okay, means multiply their mass with their position vector and upon the sum of the masses m1 plus m2 plus m3 plus dot mn. So that was the mass of sum of the mass of that particle system, we can take as capital M that value. So you will get sigma I is equal to 1 to n summation I is equal to 1 to n m I r I vector will be the value of RC. Similarly, if you take the coordinate axis, so XCM vector is equal to sigma I is equal to 1 to n mi xi upon total m. Similarly, YCM is equal to sigma I is equal to 1 to n mi yi upon m. So ZCM equal to sigma I is equal to 1 to n mi zi upon m will be the value of ZCM vector. So that are your question. So we can say similarly that XCM is equal to integration, because summation is integration. When the sum will be came, so we will take derivation. So one, sorry, integration. So 1 upon m xdm will be the value of position vector, or 1 upon m integration ydm will be the position vector, or 1 upon m integration zdm will be the position vector. Now momentum conservation and center of mass motion. Next topic is momentum conservation and center of mass motion. So suppose the particle is here, the position coordinate are x, y, z. Suppose that was your particle as position m1 at r1 vector, m1 at r1 vector, m2 at r2 vector, mn at rn vector. And if I apply total force, so the total force will be, if in the external total force will be F total, but in the absence of any external force, so in the absence of any external force, in the absence of any external force, F total equal to 0. So if F total equal to 0, so F1, F2, F3, Fn will become 0. So the value of Fn F1 will be m1 a1 vector plus m2 a2 vector plus m3 a3 vector plus dot 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 mn an vector will be 0. Now what is mn a1 vector? A1 is known as d by dt of v1 vector. So F1, F2, F3, M1, M1 A1, M2 A2, M3 A, Mn A and B 0. So A1 equal to d by dt of V1 vector plus M2 is equal to d by dt of V2 vector plus M3 is equal to d by dt of V3 vector and plus dot 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 n plus d by dt of Vn vector. M and d by dt of V1 vector is equal to 0. So if you take d by dt common, so m1 v1 vector plus m2 v2 vector plus m3 vector and dot 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 m and v and vector is equal to 0. So all that are d by dt of p1 plus p2 vector plus p3 vector dot p n vector will be zero. So that means p of center of mass will be zero. So if derivative of any function will be zero, so that function will be constant. So pcm is equal to constant. That means the momentum of the particle will be constant. Now next is equation of rotational motion. Now in the rotation motion, so firstly there are two type of motion. Translation was directly. Now comes to rotational motion. Rotational motion in which a particle is rotating. So that motion is known as the rotational motion. Now suppose the particle rotation, it was at its fixed point. Okay. So suppose that was the particle rotating in a fixed axis having radius r. So suppose it moved an angle theta, and that was its displacement. Displacement is denoted by s. So from point A to B will be its displacement. So the theta is equal to s upon r, means arc upon radius. Arc is their linear displacement, and that is your angular displacement. So the angular displacement theta is equal to linear displacement upon radius. Linear displacement s upon radius. So its SI unit will be radian. SI unit of theta will be radian. Okay. So theta is equal to s upon r. Theta is equal to s upon r. So s is equal to theta into r. Now next is your angular velocity. That was your angular displacement is equal to linear displacement upon radius. Now next is your angular velocity. Angular velocity. Angular velocity is denoted by omega. अच्छा, wait हाँ. SI unit is radian of theta. SI unit of theta is radian, and its dimension will be dimensionless. M0 L0 T0. Angular velocity is omega. So omega equal to d theta by dt. So d by dt of s upon r. So 1 upon r ds by dt. So ds by dt is equal to v. So omega equal to vr, v upon r. So v equal to r omega. That was the relation between angular velocity and angular displacement. So omega equal to v upon r. So SI unit of omega will be radian per second, and dimension will be radian has no dimension, and second have dimension of t. So m0 L0 t minus 1 will be the dimension of omega. Now next is your angular acceleration. Angular acceleration. So angular acceleration is denoted by alpha. Alpha is equal to d by dt of omega. Rate of change of angular velocity is known as omega. So d by dt of v upon r is known as omega. So 1 upon r dv by dt is known as alpha. 1 upon r dv by dt is a. So alpha is equal to a upon r. So alpha is equal to a upon r, or you can say that a is equal to r alpha will be the relation between them. So alpha is equal to AR. So SI unit of alpha will be radian per second square, and the dimensional formula of omega is m0 L0 t minus 1. So the dimensional formula of angular acceleration will be m0 L0 t minus 2. Okay, that was your angular displacement, angular acceleration, angular velocity, angular displacement, and angular acceleration. So in the rotational motion, firstly we are talking about angular displacement. Second one is your angular velocity, and third one is your angular acceleration. Now comes to the equation of rotation motion. Equation of rotation motion. Rotation motion. We know that alpha is equal to d omega by dt. So d omega equal to alpha dt. Now at t equal to 0, omega equal to omega naught. That was its initial angular velocity. And at t is equal to t, omega equal to omega. That was its final velocity. So integration omega naught to omega d omega equal to alpha dt 0 to t. So d omega omega naught to omega alpha dt 0 to t. Now differentiation removed by integration. So omega equal to omega naught upon omega is equal to alpha dt is t 0 to t. So you will get omega minus omega naught equal to alpha t minus 0. So omega minus omega naught equal to alpha t. So omega equal to omega naught plus alpha t. That means final angular velocity is equal to initial angular velocity plus angular acceleration into t. Now second equation of motion is, we know that omega equal to d theta by dt. So at t equal to 0, d theta equal to omega dt, and the value of omega is omega naught plus alpha t into dt is equal to d theta. So at theta equal to 0, at t equal to 0, that means at 0 time distance will not cover, so angular displacement will be 0 at that time. At t equal to t, theta equal to theta. So on integration, you will get integration d theta from 0 to theta equal to 0 to t omega naught plus alpha t into dt. So you will get omega naught integration dt 0 to t plus alpha t dt integration 0 to t or integration d theta equal to 0 to theta. So we know that integration of x की power n dx is equal to x की power n plus 1 upon n plus 1. Here is integration t dt. So t dt is known as t की power 1 plus 1 upon 1 plus 1. So t square by 2. So omega naught dt is known as t 0 to t plus alpha t square by 2 0 to t, and d theta is theta from 0 to theta. So you will get theta minus 0 is equal to omega naught t minus 0 plus alpha t square minus 0 by 2. So you will get theta is equal to omega naught t plus half alpha t square. So theta is equal to omega naught t plus half alpha t square will be the second equation of motion. Now come to the third equation of motion. We know that omega alpha is equal to d omega by dt. Now multiply, I am multiplying it by d theta and d theta because that d theta by d2 will become omega. So omega d omega by d theta is known as alpha. So on solving, you will get alpha d theta is equal to omega d omega, omega d omega. We know that at theta equal to 0, omega equal to omega naught, and at theta equal to theta, omega equal to omega. So alpha d theta from 0 to theta equal to omega naught omega from omega d omega. So alpha is constant that come outside. 0 to theta equal to omega d omega from omega naught to omega, and now integration omega d omega is omega square by 2. So alpha theta is equal to 0 to theta, and omega square by 2 is from omega naught to omega. So alpha theta minus 0 is equal to 1 upon 2 omega square minus omega naught whole square. So you will get 2 alpha theta is equal to omega square minus omega naught square. So omega square is equal to omega naught square plus 2 alpha theta will be the third equation of the rotational motion. So student, that's all for today. In the next class, we will discuss some